Hi everyone, welcome to Unit 7, which is all about exponents and exponential functions. Today you're going to learn the first 3 rules for multiplying exponents. So a couple key vocabulary before we start. The first one is called a monomial. And we'll have a whole unit on polynomials and how to work with polynomials, but a monomial, if I can get this to work. Here we go. A monomial is a number, variable. It can be a number, a variable, or product of a number and one or more variables. So mono means one, so it's just one term. So that's the shortcut definition, one term. So for example, a monomial could be 5, it could be 5x, or it could be 5x squared y. All of those are monomials because they're just one term. They're all multiplied together, not separated by addition or subtraction. And then a power is, a lot of times we interchange power with exponent, but a power is the actual, like the entire term. So for example, if you had 5 squared is the power, where 5 is called the base, and the little number up here is called the exponent. And as you know, that's the number that how many times you multiply the base by itself. So if that means 5 times 5, if it's to the power of 2. All right, so the whole thing is called the power, and then the little part up here is called the exponent, or the superscript. All right, so the first rule is the product of power. So if you take 2 powers and multiply them together, you add the exponents. So make sure you take a minute to write down the whole rule and this entire box here. And make sure you write down that entire box. You want to make sure that you stay organized with these rules because there are a lot of them and they can get jumbled up easily. So here, if we have 5 squared times 5 to the 4th, it would be 5 to the 6th. I think about it as like, if I have these bases the same, and the bases have to be the same, they can't be different. So if they're not the same, then you can't multiply them together. So anyways, if I see those bases the same, I think of putting like a plus sign in between them. So I know 2 plus 4 is 6. Okay, and this comes from, because we know that 5 squared is 5 times 5, and then we know that 5 to the 4th is 4 5, so 5 times 5 times 5 times 5. If we write all of that together, we have 6 5. So that would be, if we wrote it back as a power, it'd be 6 to the 5 to the 6th. All right, so here for number 1, y to the 4th times y to the 3rd times y. Now, one thing to remember is that just y actually does have a power. Its power is 1, so you can't forget that. So here we do 4 plus 3 plus 1 is y to the 8th. Now here, you're still multiplying, you're just using parentheses. So the first thing you do is multiply the coefficients. 7 times 6, which would be 42. And then you do a to the 5th times a to the 1st. So when you multiply powers, you add the exponents. So a to the 6th. When you multiply powers, you add the exponents. Now here we have a negative sign here, so we'll put the negative in front. And then we have 3 times 5 is 15. And then the x's would be x to the 2nd times x to the 1st, so that'd be x to the 3rd. And then the y's would be y to the 7 plus 6 is 13. So remember, add the exponents. All right, now here, this is tricky because one thing to note is that if you have negative 5 in parentheses and you square it, you're taking negative 5 times negative 5. Now you have 2 negatives, so that would turn into positive 25. Okay, or likewise, if you would have to the 4th power, you would have 4 negatives and it would come out to be positive. So anytime you have an even exponent, the negative sign goes away. But if you have an odd exponent, so for example, negative 5 to the 3rd, then there will always be 1 negative left over. So it'll be negative 5 to the third. Okay, so that's one thing to remember. So here you have, if you wrote this, this would be negative 5 to the 7th, but one rule of writing, of simplifying powers, is that you can't write your final answer with parentheses. So you'd have to say, okay, is this going to be positive 5 to the 7th or negative 5 to the 7th? Well, since the 7 is odd, the power is odd, or the exponent is odd, that means the power is going to stay negative. So negative 5 to the 7th. Now here, it would be negative 5 to the 6th, because 1 plus 5 is 6. And since the power is even, since the exponent is even, the power is going to become positive. So this would be positive 5 to the 6th. All right, here you would have negative 7, and then 1 plus 3 plus 4 is 8. So since the power, the exponent is even, the power will become positive 7 to the 8th. So just in summary, if you have an odd exponent, then the power will become negative. If you have an even exponent, the power will become positive. Now, one tricky part of this is if you have negative 7 to the 8th. So if the negative is not in parentheses, then it's not being raised to the 8th power. So it's just negative 7 to the 8th. All right, that's kind of tricky, but I encourage you to type in your calculator negative 7 to the 8th without parentheses, and then negative 7 to the 8th with parentheses, just like that, and see what they are equal to. This one will be negative, this one will be positive, because here the negative sign is not being part of this exponent, where here it is. All right, the next rule is quotient of powers. So quotient means to divide. So division is the opposite of multiplication, and in the last rule, we learned that if you multiply powers, you add their exponents. Well, if you divide powers, you subtract the exponents. Okay, so it's just the opposite. So here, if you divide a to the m over a to the n, you subtract. So here, y to the 6 over y to the 2nd would be y to the 4th, because 6 minus 2 is 4. Right, so here, 6 to the 13th over 6 to the 2nd would become 6 to the 11th. Now here, this one's tricky because 10 to the 15th, 10 over 15 does not simplify. You just divide it like you normally would a fraction. So reduce 10 over 15 would be 2/3. And then we'll figure out what's left. So a to the 7th over a to the 5th would be a squared, and you put it in the numerator. So you're going to write the final answer in either the numerator or denominator, depending on which one is bigger. So since a to the 7th was bigger and it's in the numerator, you write a squared in the numerator. Now b to the 9th over b to the 9th, that's just going to cancel. So you're not going to have any b's left. Okay, so if we wanted to write this maybe a little more appealing, you would do 2a squared over 3. Or you could also do 2/3 times a squared. Okay, those are all equivalent. Sorry, I keep pressing the wrong buttons here. Number 3. So we have a to the 5th, or x to the 5th over x to the 1st would become x to the 4th. Y to the 6th over y to the 3rd would become y to the 3rd, because you subtract. Number 4. 52 over 13. I believe that is 4. And then you have 6 minus negative 7, which is going to become minus negative plus positive, so that would become 13. So that would be x to the 13th. All right, 9 minus 3 is 6, so then you would have negative 3 to the 6th. Now, since the negative is in the parentheses and the exponent is even, then it's going to become positive 3 to the 6th. So you can't write your final answer with parentheses. You have to get rid of the parentheses and figure out if your final answer is going to be positive or negative based on the exponent. All right, here. So we have 1 to the 4th. What I encourage you to do is rewrite, whenever you see something like this, rewrite it as 1 over x to the 4th times x to the 6th over 1. And then combine, so multiply the fractions. So it'd just be x to the 6th over x to the 4th. And then you can subtract the exponent. 6 minus 4 is 2. So x squared would be your final answer. All right, so we have one more rule to learn about negative exponents. So for any non-zero negative a raised to a negative exponent, or a number a, place the power in the denominator to rewrite the power with a positive exponent. What does that mean? Well, essentially, anytime you have a negative exponent, we want to make it positive. In order to make it positive, you flip it. So if it's in the numerator, you move it to the denominator. If it's in the denominator, you move it to the numerator to make it positive. Then once you do flip it, then it can become positive. So here we have a to the n, negative nth. Since the exponent is negative, we flip it. So we do 1 over a to the nth. So if you had x to the negative second, you would write 1 over x squared. Now let's say you had 1 over x to the negative second. Well, since this is in the denominator, you'd make it positive by flipping it and moving it to the numerator. So x squared over 1, or just x squared. All right, so here's an example. 2 minus 5 is negative 3. So you'd have b to the negative third. And then if we want to make it positive, the exponent, you would flip it and make it 1 over b to the third. So one other thing, if you remember from one of the last examples that we did, I said that when you subtract, you move you write the power in the part of the fraction that was bigger. So if b to the fifth is bigger, then all of these two b's will cancel out, and here you'll have 3 b's left in the denominator. So that's another way to think about these kind of questions. So then you'll just have 1, because the b squared canceled, and then you'd have b to the third in the denominator. Okay, so you can think about it like this, like negative exponents, or you could just think about which ones cancel and where will my variable or my power be left. All right, so we're going to simplify the expressions, rewriting all negative exponents as positive. So 2 to the negative third we're going to just flip it, so 1 over 2 to the third. And you'll just leave your answer like that. So don't get confused with a negative base and a negative exponent. If the exponent is negative, the first thing you want to do is make it positive by flipping it. So 1 over negative 3 to the third. Now, since we can't have parentheses, so since the exponent is odd, the negative sign is going to stay. So we'll have 1 over negative 3 to the third for that final answer. Right here, the negative power is in the base, so you would move it up, the denominator. So you move it up to the numerator. So just be x to the fifth. All right, here. Now this one is pretty tricky. So first we want to flip the fraction, but since it's already a fraction, we can just think about it as just flipping this fraction. So negative 5 to the positive second. All right, so if you have a fraction being raised to a negative exponent, to make it positive, you would just take the reciprocal of that fraction. Okay, and then since the exponent is even, you would just make it positive 5 squared. All right, and then here. So actually, we're going to skip this example because this is more like what we'll do tomorrow or the next lesson. For number 6, what we're going to do first would be to add the exponents here. So because we're multiplying, so this would be negative 3 to the 7th. And then we will get rid of the parentheses. Exponent is odd, so the negative sign stays. All right, so that is all for this lesson. The exit ticket will be included in the Polaris folder, so make sure once you're done with this lesson, you take the exit ticket. All right, you guys have a great day.